now we're going to work through the Einstein and Brown formula to calculate our bed load transport and then compare it to the Mayer-Peter and the Kalinske-Fridge-Lick result. So the first step we should do, calculate the K. Well, we know viscosity is a constant, 1 times 10 to the negative 6 meters squared per second. S, we know from our channel, is 2.65. D is our D50, 0.2 millimeters. If we put everything in, I won't invest time in this, we should get a K equal to 0.445. Okay. Now, K is done. Let's calculate the effective Shields parameter. So, the effective Shields parameter, very important. Friction velocity squared, S minus 1, GD. That's the Shields parameter for effective. So how do we get it? We calculated in the past video that our effective shear stress was 6.4 newtons per meter squared. So that is the way you will calculate your effective Shields parameter. So if you plug in the numbers, we should get 6.42 newtons per meter squared divided by density of water, 1,000 kilograms per meter squared. This divided by 2.65 minus 1. Gravity is 9.8 meters per second squared. D, as we already said, is 2 millimeters, but we transfer it 2 meters. We carry out this calculation and our effective Shields parameter should come out to be 1.98. Okay, that is done. Now that we know the K and the Shields parameter, we also know D. We know everything we need to know. So we plug it in. 40 times RK, 0.445 times R 1.98 to the power of 3 times this term here, 0.0002 meters times the square root of 1.65 is 2.65 minus 1, 9.8. And again, our famous D50. So, boom, 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 boom. We have everything we need according to Einstein. This comes out to be QB, our bed load transport, is 0.01572 meters cubed of sediment per meter of width of channel per second. So this is the answer of the bed load transport according to Einstein. So how does this compare to Mayer and Peter? Well, I encourage you to work through that. You should get that the bed load transport is 0.0024 meters cubed per meter per second. And if you work through the Kalinske-Fridge-Lick, you get even a smaller number, which is 0.000041 meters cubed per meter second. The difference between these two, I would say, is about 5, a factor of 5. Difference between these two, I would say it's a factor of about 7. Difference between the lowest and the biggest one is then about 35 times. That's a big difference. In this special case, the 3 formulas gave us very distinct answers. What we can say is that since we have a rather small sediment and high velocity, these factors somehow played out and gave us different answers regarding to the bed load transport. So we will go now and discuss suspended sediment transport.